Okay, this is Mr. C doing a Zoom meeting for Math 1113. We are here, and I have just noticed that I had an old edition of the book, and the basic material I was supposed to cover was in Chapter 5 and not Chapter 6. So the assignments, if anybody read the assignments or looked at them from last night, and the calendar shows Chapter 6, we're going to have to back up a chapter and go to Chapter 5. And we'll probably do 5.1 and 5.2 this week. I will repost the assignments and repost the calendar showing this, and I apologize for the confusion. This week, sections 5.1 and 5.2. This is the basics of trigonometry. And if you want a single definition of trigonometry, it relates angles to lengths of sides of triangles. It all works off your standard XY axis. If you take a ray, here called the radius, swing it in a circle, at any point you start from here and point up. If r equals 1, it's called a unit circle. At any point you stop, you're on a circle. You're starting at coordinate here, 1, 0. Up here, you're at 0, 1. At any point you stop, there's an X leg and a Y leg to the triangle. And you're always governed by Pythagorean theorem. That x squared plus y squared equals 1. You'll see a couple of symbols used for the angle. See this symbol used for the angle. Very common to use this symbol. It's called a theta. You will also see T used. They don't use X for the angle because it's too confusing with X on the length of this side. So what section 5.1 is about is about how we measure angles. And you may have seen this before. The most common real world, or in the real world, is degrees. They use little circle. Circle like this. This would be 57 degrees. Okay. The x-axis is 0 degrees. Everybody know if you go all the way around, you're at 360 degrees. If you go around again, you're at 720. You can go around forever, and this just increases by 360. You can go backwards. This is positive angle. Negative angle goes the other way, and you could be at negative 360, negative 720, and so on. All right. Halfway around, you're at 180 degrees. Up here, you're at 90 degrees. Down here, halfway between 100 and 360 is 270 degrees. Halfway to 90, you're at 45 degrees. We can call this the degree system. Halfway between 90 and 180 is 135 degrees. Halfway 180 to 270 is, what was it? You can always average it. 180, add 270. I used to have this memorized. I divide by 2. I think you're at 240. Add 270, divide by 2, you're at 225. Yeah, that's right. I'm embarrassed I didn't know that instantly. And then this is, I believe, at 315. Once again, halfway, 270, add 360, divide by 2, you're at 315 degrees. Other important angles we're going to see and explain why. Are 30 degrees and 60 degrees, and their equivalents in other quadrants. So there's 30 degrees, 60 degrees, 30, really you're 30 from each axis, but this would be called the 60 equivalent. Up here is, let's see, up there, this is 150 degrees, and 15, 30, this is 120 degrees, and then 30 from here, you're at 210. 30 from here, you're at 240. Notice how you're 15 off in between here. And then down here, you're at 300, 315, then 330, 30 from 360. Okay, you see how messy the diagram, if you try to give the entire complete picture, you see how messy things get very quickly. Okay. I don't know if the book just sort of assumes that you know the degree system, but I like to remind everybody of it because they're going to start on page 438 with radians. This is what's used in school. Same diagram. You drop the little circle. occasionally you might see a 0 little r, but they usually don't even do that. If you just see numbers, it's radians. If you see numbers, it's radians. And it turns out that if you go all the way around, you're at 2 pi. Again, you're drawing a circle around. We'll use r equals 1 for the unit circle. You're, again, starting with coordinate 0, 1. You're up here at, 1, 0. Here you're at 0, 1. Here you're at -1, 0. And here you're down to 0, -1. Swing it all the way around. Sorry, lousy circle. If you want to know, gee, why is that 2 pi? Well, if you remember, there's a formula for circumference of a circle. It equals, they usually use C equals 2 pi r. You remember that? That's the distance all the way around a circle. Circumference C equals 2 pi times the radius. And if r equals 1, then your entire circumference is 2 pi. Once around, 2 pi. Okay, again, same game with degrees. You could go around again and get 4 pi, 6 pi, 8 pi, infinite numbers. Any even multiple of pi is referring to this point. You could go backwards, -2 pi, -4 pi, -6 pi. And again, there's infinite angles to refer to any point, depending on how far you've gone around and which direction. Well, if this is 2 pi, halfway, you're at pi. Once again, that could be 3 pi. Again, add 2 pi around, you could be at 3 pi. You could be at -pi. All refer to the same spot. 5 pi. Any odd multiple of pi refers to this. Odd multiple of pi refers to this. These are even multiples of pi. Well, if you're halfway to pi, you're at pi over 2. This is where the fractions come in. Half pi. This is at 3 pi over 2, 1.5 pi. You refer to that. Again, you could get it by pi, add 2 pi, divide by 2. Pi plus 2 pi is 3 pi, divide by 2. Half of this halfway up, pi over 4. Three pi over 4. You want to halfway there. It's in effect 45. This is like a 45 equivalent. Pi over 4 is a 45-degree equivalent. You can count around 1 pi over 4. This would be 2 pi over 4. You'd be at 3 pi over 4 here and 4 pi over 4. If you wanted to average it, you could go pi, add pi over 2, and divide by 2. Common denominator, you'd get 2 pi over 2, 2 over 2, so you're making 3 pi over 2 over 2. 3 pi over 2 times 1/2. This bottom flips around when you divide fractions, 3 pi over 4. I don't know if that makes it any clearer. I prefer to count around. 45 degrees, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Well, you just keep counting around. So this would have to be 5 pi over 4, 4, this would be 6 pi over 4. So guess what this would be? 7 pi over 4. And you'd finish at 2 pi. 8 pi over 4. So this would be 9 pi over 4. Again, you can keep going on around forever. Okay, well, my diagram is going to get really, really bad. We need to do the 30-degree and 60-degree equivalents in radians. This is called radian degree to radian. Conversion. If you remember around the circle, previous page, this is 360 degrees and 2 pi. We could use that, basically 2 pi equals 360 degrees. You can divide both sides by 2 and get that pi is equal to 180 degrees. Divide by 180 degrees. Pi over 180 degrees equals 1. You can flip, and 180 degrees over pi equals 1 as well. These are conversion factors. So if I want to convert 30 degrees to radians, start with 30 degrees, and I got to use one version or the other of this. And I use the version, if you've had any chemistry, you know about unit conversions, with the 180 degrees on bottom so that the degrees cancel. I have pi here. Well, how many times 30 go into 180? Well, if you want to get rid of the 0, it's 3 into 18, leaves a 6. It's pi over 6. Now, you might can guess 60 degrees would double. But just to work that out, 60 degrees times pi over 180 degrees. 60 into 180 would be pi, and leave a 3 down here. You cross off this, you leave a 3 pi over 3, which sure enough is twice 2, which is equal to twice pi over 6. Twice this, 2 and 6 3 times. Okay. We're going to have these, in other words, the 30-degree equivalent, you're at pi over 6. 60 degrees, you're pi over 3. And in the middle, you have pi over 4. Let me give you the equivalents all the way around the circle. This is the 30 degree, 60 degree, or pi over 6, pi over 3 around the circle. Pi over 6, 0, pi over 3, in the middle, pi over 4. So if I come over here, you basically got 3 rays in every quadrant. Remember your pi here. Call this 1 pi over 6. You can call this 2 pi over 6. You're at 3 pi over 6 here. That's your pi over 2. So guess what? This is 4 pi over 6, but that reduces to 2 pi over 3. You skip this one because that's your 3 pi over 4. Your pi over 4 equivalent. You'd be at 5 pi over 6, and you're at 6 pi over 6 here. Basically, you can get them by just counting around. you count by 30 degrees. One pi over 6, 2 pi over 6, 3 pi over 6, pi over 2. 2 pi over 6 is pi over 3. Anything that can reduce gives you the 60-degree equivalent. So in other words, there is 60 degrees from here to here. 45 degrees to the pi over 4 and 30 degrees up to the pi over 6. Same thing here. These, by the way, in the first quadrant, they're called reference angles. Okay, well, you got the same thing in the other two quadrants. 30 degrees down, let's see here, 5 pi over 6, 6 pi over 6, 7 pi over 6. You're at 8 pi over 6 here, because remember this was 5 pi over 4. 4 pi over 4, 5 pi over 4. 8 pi over 6 reduces to 4 pi over 3. You're at 9 pi over 6, but that's 3 pi over 2. The next one would be 10 pi over 6, but that is 5 pi over 3. Your next one, 7 pi over 4. Hope you all have this memorized as good as I do. I missed a couple of details earlier, but it's coming back to me. And then 11 pi over 6, because you're back to 12 pi over 6 here, which is 2 pi. And I could keep going. This would be 13 pi over 6, 14 pi over 6. If you just keep adding 2 pi, you just keep counting around. So they want to give you, let's just do another example. They'll have you say convert, this is just an example, 210 degrees to radians. You go 210 degrees times pi over 180. Okay, your degrees cancel. Zeros cancel. It's a matter of reducing 21 pi. 21 pi over 18. Well, 3 goes into 21 7 times. 3 goes into 18 6 times. There's 7 pi over 6. Let's say you wanted to reverse it. Convert 7 pi over 6 to degrees. You'd have 7 pi over 6, but this time you multiply by pi, put the pi down here, because that's 180 degrees up there. Pi's cancel. 6 goes into 180 30 times. 30 times 7, 210 degrees. Try some examples out of the homework here. I think to avoid the confusion, to avoid a lot of confusion, there's more systems around and we'll get to them later. But for right now, why don't we just try some examples? And homework here is off page. And again, I'll re-send out the assignments. This is for 5.1, page 444. This is about converting degrees to radians and radians to degrees, and finding terminal and coterminal angles, and etc. Okay, so the very first problem here, I'll point it out, very first problem is number 5 down here at 15 degrees. can find the radian measure of the degree angle with the degree measure round to 3 places if it doesn't work out clean. All right, so this is page 444. Number 5. Basically, I want you to convert 15 degrees to radians. 15 degrees, and I multiply by 180 degrees over pi, or under pi actually. Again, you want to line up the units. I reach for a calculator. I don't know how many times 15 goes into 180. It does go clean because they're both 1 ends in 5, 1 ends in 0, so it's going to be 5. So I can go 180 divided by 15. Comes up 12. So 15 goes into 180 12 times, and I wind up with pi over 12. It did say round to 3 decimal places, so I could go pi divided by 12 and get 0.261799. But it said round to 3 places. So if you're going to round to this place, you look at this. So it's 5 or bigger, you'd round that up to 0.262. I'm not really that picky about the rounding. This is radians. A lot of people get confused about radians. Maybe I should point this out. Well, that leads to another system and the like. Maybe I should just stick to the book and we'll point it out later. Try another one. What about something with a real number, or like 1,000, like 13, 1,000 degrees? Convert to radians. All right, you've gone many times around the circle to get to 1,000 degrees, because once around is 360. Well, not many times. Actually, you've gone about a little over 3 times, because at 360 times 3 would probably get you to a little over 1,000. You've probably gone greater than 3 times around the circle to get to 1,000 degrees. All right, so I go 1,000 degrees times, again, 180 is pi radians. If you want to just get directly the decimal and not your fraction of pi, you can just literally punch this. 1,000 times 180 and divide by pi. Round it to 3 places, and you're at 57,295.73 places. We'll call it 78. You're going 1,000 times pi over 180. And I have reversed it. Good morning this morning. 1,000 times pi and divided by 180. Okay, you're at 17.453 radians. Notice I don't put any circle or anything. I don't even put an R. This is by definition in radians. If you wanted some sort of fraction of pi, you could cross off a 0 here, cancel the degrees. You'd have 100 pi over 18. That would be 50 pi divided by 9. It's as low as you're going to get it. If you wanted to double it, convert that, 50 pi divided by 9. And there's your same answer. 17.453. All right, let's go the other way. This is in section 17, page 444. Convert 5 pi over 3, 2 degrees. If you look at the diagrams I showed you earlier, you should be obvious if you get this memorized. 5 pi over 3 is the 60-degree equivalent. Actually 60-degree equivalent this way. It's 30 degrees this way. 5 pi over 3. So it should be 300. Watch me have totally outsmarted myself. This was a 270 plus 30 would be 300, or 360 minus your 60 would be 300. Let's see, 5 pi over 3. You go pi there, 180 degrees there. Pi's would cancel. So you're getting 5 times 180 divided by 3. 3 goes into 180 60 times. 60 times 5 is 300, and you got to put a circle for degrees. Must put circle, little circle, 4 degrees. But yeah, it's something that's a standard value off the circle. You can kind of puzzle it off in your head if you know what you're doing. Sometimes I do, sometimes I don't. Okay, what about a odd one like 23? Convert negative 1.2 to degrees. Now, negative 1.2 is going to be down somewhere this direction. But I go negative 1.2 times, put the pi here, in 180 degrees. And there's no point really, with all the decimals here, there's no point really messing with fractions of pi or anything. So negative 1.2 times 180 and divide by pi. Negative 68.755 degrees. That went too fast. So it's down in the fourth quadrant because this would be negative 90. You're down into the fourth quadrant, negative 68.755 degrees equal to negative 1.2 radians. Let's try coterminal angles. 29. $50 degrees. Find 2 positive and 2 negative coterminal angles. Coterminal angle comes to the same ray, has the same ray. So if I draw a ray here and go around to the same ray, let's say it was at 45 degrees is the first. All right, the next positive coterminal would be 45, and you'd add 360 because you've completed an entire circle getting back. 45 and 360. $405 degrees. 405 degrees. But one of the next positive coterminal, I go 405, add another 360. 765. If I wanted the negative coterminal, I go 45 and subtract 360. Because in effect, I'd be going the other way around, the full 360. Negative 315, etc. So try 29, 50 degrees. Your first positive coterminal, 50 add 360, aren't you going to be at 410? 50 degrees add 360, 410 degrees. Next, positive coterminal, 410 add 360 plus, there, I'll just do it in my head, 770 degrees. First negative coterminal, degrees subtract 360 degrees, wouldn't you be at negative 310? Next, wanted two positive and two negative coterminal angle would be negative 310, subtract 360. Negative 670. You may or may not get the answers in the book, depending on which direction you go around and the like. You can get other answers that are correct that are not in the back of the book. All right, we're going to call this meeting at there. Well, let's see. Let's try one more, 41. Well, let's try 35 first. 35. They give 70 degrees for 30 degrees. Question is, are they coterminal? Well, you could do it simply. You could start with 430, subtract 360. Point is, are they 360 apart? So I'm going to take 70 degrees and add 360. 70 plus 360 is 430 degrees. Yes, coterminal. I start at 70 degrees, should be just short of 90. I add 360. You get to the same, which is a full circle, and you come back to the same point. Try 41 real quick. Find a coterminal angle between 0 and 360 for 400 degrees. All right, since 400 is greater than 360, I'm going to subtract 360 degrees to bring it between 0 and 360. So I'm going to go 400. Here's my answer. I'm going to go 400, subtract 360. That would be 40 degrees. That is a coterminal angle between 0 and 360, coterminal with 400 degrees. All right, basically the bottom line is this week we're going to do 5-1 and not 6-1. Section 5.1, not 6.1. No WebAssign assignments this week. I will make out a new calendar and assignments. Thank you very much, and hope you all have a good week.